Hello everyone, welcome to lecture number 11 of Engineering Mechanics. In today's lecture, we are going to learn about the truss, classification of truss, assumptions in truss analysis, and methods of truss analysis. So let's start. Truss. So the first question arises in our mind is, what is truss? So basically, a truss may be defined as a structure made up of several bars riveted or welded together and constructed to support loads. So this is the very basic definition of truss, and after looking at this definition we can see that truss is nothing, it's just a structure which is made up of several bars which may be riveted or may be welded together, and these trusses are made to support some loads. We all have seen truss in our daily life, such as electrical transmission towers, mobile towers. They all are made up of several bars which are welded or riveted together to form these structures. These structures are supposed to carry the loads of the routers which are mounted on these towers, or the electrical wires which transmit the electricity from one area to another. The other example we can see in the form of bridge. These bridges are also made up of several bars like this. These are the several bars, and these are made to carry the loads. These are few examples of truss. So by seeing these examples, now you have understand that what kind of structure we are talking about. There are various kind of trusses which we have come across, which we are going to study in classification of truss. So trusses are classified according to their behavior upon loading. Generally, trusses are classified into two categories: perfect truss and imperfect truss. Imperfect trusses are further classified into deficient truss and redundant truss. So let's discuss these types of trusses one by one in detail. So the first one is perfect truss. A perfect truss is that which is made up of members just sufficient to keep it in equilibrium condition when loaded without change in its shape. This is the very simple perfect truss which has three members, namely 1, 2 and 3, and these members are pin jointed at this position. So there are three members which are riveted or pin joined at the joints A, B and C respectively, and these are the reaction force R1 and R2. So this is very simple perfect truss. Now the question arises that how can we tell, or how can we say that the truss given to us is a perfect or it is imperfect. So basically we have an equation by which we can say that the truss is perfect or not. The equation is M is equal to 2J minus 3, where this M is number of members, J is number of joints. So in this particular truss we can see that the number of members of this truss are 3, 1, 2 and 3. The number of joints A, B, C are also 3 in this situation. So 2 into 3 minus 3. So 2 into 3 is 6 minus 3 is 3. So 3 is equal to 3, which means that this truss satisfies this equation, so we can say that this is a perfect truss. If any of the truss which cannot satisfy this equation is termed as imperfect truss, which we are going to see in another slide. Imperfect truss. An imperfect truss is that which is made up of members but not in equilibrium condition when loaded. Upon loading, if a truss collapses or it becomes statically indeterminate, then we can say that the given truss is imperfect. Here is an example of an imperfect truss, which is deficient truss, which means that upon loading, this truss will collapse. Now, how can we say that the given truss is deficient truss or not? So, M is less than 2j minus 3 is the condition where we can term the truss as deficient, which means it can collapse under the loading. Now let's see if this given truss can satisfy this equation or not. And number of members, there are 1, 2, 3 and 4. 4 members. Number of joint, 1, 2, 3 and 4. 4 joints. So let's put this in the equation. Number of members are 4. Number of joint, 2 into 4 minus 3. 2 4s are 8. 8 minus 3 is 5. So clearly the equation is satisfied and the truss is the deficient one. Here's an example of redundant truss. Now let's see if this equation will satisfy for this truss. Number of members, again let numbering it 1, 2, 3, 4, 5 and 6. There are 6 members. Number of joints 1, 2, 3 and 4. So number of joints are 4 minus 3. 2 4s are 8 minus 3 5. So this equation indicates that the truss is the redundant truss. The redundant truss will not collapse under the given loading, but it will become statistically indeterminate, which means the equations of equilibrium are not sufficient to calculate the forces. Now next is, while solving the numericals or doing the truss analysis, we have to take into account some assumptions. The first assumption is all members are pin jointed and frictionless. The very first assumption here is that we have to keep it in mind that there is no friction, so no force is wasting to overcome that friction. And second is load on the truss are applied at the joints only. No load is applied on the member, the load is only applied to the joints. This is the second assumption. Let's see the third one. Truss is a perfect truss. For solving a numerical or doing the analysis of a truss, we have to consider that the truss given to us is a perfect one. We can also check that the truss is perfect or not by satisfying the equation n is equal to 2j minus 3. But most probably the numerical given to us or the truss given to us is the perfect one, so that we can carry out the analysis. The last one is the weight of the members, unless stated otherwise, regarded as negligible for solving the numericals. If the weight of the members are given in the numerical, then we have to consider that weight. If the weight of the members are not given in the numericals, then we have to consider that there is no weight in the members, or we can say that we have to neglect the weight of the members and only taken into account the forces, the loads acting on that truss. Now the next thing is methods of truss analysis. How to do the truss analysis, how to calculate the forces in the truss. So there are two methods, joint method and section method. By using these two methods, we can easily calculate the forces induced in the truss when the truss is loaded by some forces. One more thing we have to see over here, that we are talking about the equilibrium condition, and a perfect truss is always in equilibrium. And to solve the forces and to calculate the forces in equilibrium condition, we have to apply the equilibrium equations, and we have only three equations of equilibrium, that is sigma fx is equal to 0, sigma fy is equal to 0, and sigma moment at any point is equal to 0. So these three equations play an important role in these methods. When we are talking about joint method, then in this joint method we are going to use only these two equations, and while using the section method we are going to use only this equation, which means out of three equations of equilibrium we are going to use only two equations of equilibrium, that is sigma fx equal to 0 and sigma fy is equal to 0 while using the joint method, and sigma moment at any point is equal to 0 while using the section method. So that's all for today's lecture. Happy learning.